Next, multiple choice problem. If you look at this problem, you would probably start by trying to make rectangles that are vertical, and then just do a top function minus a bottom function. But after you put this in the integrand, you have to integrate it because this is a problem without a calculator. You don't know how to integrate inverse cosine. So you're going to have to turn the rectangles the other direction so that you have a function that you're able to integrate. And now we have a right x minus a left x. In order to isolate x, I need to first multiply both sides by pi over 4. Then I take the cosine of both sides, and that will cancel with the arc cosine because they are inverse functions. They will undo each other. And then the last thing is to multiply by 4. And now I have what x is equal to, because I'm going to need that for my right or my left x. The other function needs to have x isolated, so 2 minus y is equal to root x. And that gives me square both sides, x equals 2 minus y squared, which is equal to 4 minus 2y plus y squared. Okay, so now I've got my functions ready. Knowing that this is a delta y vertical cut, making it a dy integral, I need the y coordinates where this region exists, and that would be 0 to 2. Now, in this problem, it says that the region is bounded above by the arc cosine. So that means that this function is the arc cosine because it is bounded above by that function. That means that this x is the right x. So if I can get this to cooperate, my right x is equal to 4 times the cosine of pi over 4y. There we go. Pi over 4y minus the x left, which is this function, 4 minus 2y plus y squared. And now I still have to solve the integral. Because of this subtraction, I can nicely separate these two integrals. So I'm going to need to do that because of the u substitution. I'm integrating from 0 to 2 with 4 cosine of pi over 4y dy, and minus integral from 0 to 2 for the u substitution. I'm going to substitute for pi over 4y. The derivative is equal to, I'm getting ahead of myself. The derivative du dy is pi over 4. I multiply the dy over to the right, multiply the 4 over pi to the left, and I have a replacement for my dy. This is now the integral of 4 cosine u, and dy is replaced with 4 over pi times du. The limits on the integral, when x is equal to 0, when y is equal to 0, my u value is still going to be 0. When my y value is equal to 2, I plug that in, and this becomes pi over 2. So now I can integrate with respect to u and put these numbers in. And the integral of cosine is sine. So I have 16 over pi times the sine of pi over 2 is 1 minus the sine of 0 is 0. So I'm getting 16 over pi for that integral. For the other integral, I have to be careful, I'm subtracting it. Integrating with respect to y, I get 4y. And the 2 will cancel with the y squared over 2 plus y cubed over 3 from 0 to 2. Plugging in 2, I get 8 minus 4 plus 8/3 minus plugging in 0, I get 0. Blue pen really wants to exist, doesn't it? Okay, fine, I'll use you. Then maybe you'll stop emphasizing, hi, I'm a blue pen. So 8, see, it worked. Huh. 8 minus 4 is positive 4 plus 8/3, but I am subtracting that. And that's going to be 12, 20, 20/3. And now I need to see who that matches with in my multiple choice, or figure out that I did something wrong with my arithmetic. Okay. This is fun. I just keep messing up.